Welcome everyone to today's live stream. I wanted to share some more detailed compiler benchmarks, as you can see, because the last ones were slightly incomplete, and even with this benchmark you see them still takes some hours, even on this AMD Ryzen obviously. So what are we looking at today? These are now benchmarks also including optimization specific to the processor here. The AMD Ryzen Zen version 1, also maybe this should be Zen version 2, but maybe not. Anyway, and one thing you see, I show you already, starting here with the runtime performance. This is probably what most people are interested in. So the actual runtime of all of this, are they all? No, they are not all. And because not like myself, where I'm interested in build time, most of the normal users are interested in runtime. And yesterday and such, we only had here the non-Zen version 1 benchmarks. And now you see here how much faster this is with AMD Ryzen specific optimizations, because this other was default, hopefully for initial AMD 64, whatever that was back in the day, some Athlon 64, whatever, Opteron, you name it. And so now we get a more detailed look. How much faster is this here? Runtime, as usual, in seconds smaller is better. You see, for example, that here some benchmarks profit quite a lot here, quite some percentage here. This is of course size optimized, but also the others a little bit faster. But there you also see why I usually optimize for just core to do. In the meantime, in earlier times, I usually optimized my personal machine here, like this portable SSD that I usually use here. So that is that here. Can I just there? Cable isn't longer. And as I said in previous videos, I don't do this anymore because I sometimes plug this into older machines like a vintage MacBook or such, and then I would of course get illegal instructions. So in the meantime, I just optimize for core to do, just to be able to plug it in wherever I want on the go and such. And you see the difference is not that dramatic, and unless you run here some video encoding and such, you will usually don't notice. Welcome, good evening, Christian. And I wanted to share this because of course you can have luck and get some micro benchmark, some pathological case like FFmpeg and OBS and such, but otherwise for all the regular non-hugely mathematic vector optimized whatsoever, in my opinion, but as usual, leave in the comments below what you think, you will not notice this that much. But of course, faster is always nicer. So some more observations. Also, the last benchmark here had not ceiling C0 GNU-PG run because I probably hit Ctrl-C or something. I added this as well as all the GCC variants here as well. As I said, this run here 3 hours or something, even for the short running benchmark. So now you, if you wanted to, you could compare this. And as an added bonus, I wanted to spread here some awareness that ceiling has OZ, something that GCC does not have. I knew this already from macOS, from developing with Xcode there. I'm not sure if GCC on Xcode already had this patched in. I think this is some legacy of some MetroWorks or whatever that was, what Apple was using before they have done GCC, whatever that was, maybe in macOS. Maybe if you know where this zero set came from, because this zero set is even more optimized for size. And there you actually see, yesterday I was quite unimpressed with ceiling size optimization. Comparing this to GCC would of course be that line here to GCC OS there. So this was actually, it was running faster, I think, often, but you see when we look on the build time that size optimization with ceiling runs significantly longer. Usually size optimization, although don't have the camera view with the finger there, not that this would help too much, you probably better go through the lines yourself. So build time probably usually significantly, for example here, set standard is a quite complex case, so build time significantly slower, 3 seconds, so 50% slower or something. but you see here in the runtime actually that OS run faster with ceiling, often at least a little bit. You see there 1 second. And this is also the difference here with this OZ. You see runtime with more size optimized with ceiling is often slower. You see here 11 to 12 seconds and 2 to 3 seconds and such. Just rounding here a little bit just to give you a broad overview. So ceiling is not hopeless. It is looking a little bit better when you look into more details. This is also why it's often time well spent to do some more research and testing. So with more sized optimization, it is significantly better. Also binary size, so this binary size, I need to fix this footer there though, because this is not in seconds, but anyway, this is just what my script is right now printing in there. And you see size optimization often, but not always, as you see here. Not always, but often you see size optimization is even smaller here, obviously, also not as slow as GCC apparently here for this case. So there are quite some numbers you want to check out. It's not as simple as just running something randomly and getting the best thing. No, you need to research this a little bit. Also, I think when I looked at this here earlier, build time wise, that this compilation here, for example, ceiling size optimization with AMD Zen version 1 optimization, look at this, takes significantly longer, probably way more. Maybe this is even vectorizing stuff, like using this single instruction multiple data as AMD, like SSE2, AVX and such. So the compile time here increases significantly. And yeah, just to give you some overview, but runtime voice, yeah, it can be a little bit faster, but yeah, again, not by huge margin, at least not in this code cases here. I wanted to share this here to have the whole picture, the whole overview, also with the missing result here and more architecture specific optimization, as well as more size optimization added in there. And given, for me, usually for the T2 best test builds, I wonder maybe I should simply switch to 01 to just very little optimize, because obviously this build time here is way faster. This would probably save me quite some time. And if I use ceiling actually with this more size optimization OZ, it is actually not too bad. Build time wise, it is significantly faster, as you see here, what I was disappointed the other day. So you see here quite faster, like really, what is this, even 50% or something, 40-50% from the top of my head. And yeah, with OZ, so this means also my next building place, you see, the more you look at this, the more stuff you have to do, not only finish all the details from user integration to whatnot, but also next add here OZ optimization. And then the next question is, if I want to make this really nice, I would have two optimization settings in T2. For ceiling only optimize for size and optimize for even more size. The only problem is how to integrate this with GCC. Maybe makes this a no operation, that for GCC it maps to OS and you just don't get more. And because otherwise it becomes even more complicated if I want to have the size optimization only. If you select ceiling also, you see even in T2 the number of configuration choices gets slightly out of hand. So yeah, there you have it, the full open bench run there on all the most useful combinations, I guess. A bigger picture for you to have some values at hand. And I have a conference call in, I think, maybe 20 minutes. So I stop this stream and we will straight continue with another short stream in this new style of short live streams. So if you want to hear some more points that I wanted to share, don't forget to tune in a minute or two, and otherwise don't forget to share, like and subscribe, and I hope you learned something.